November 2020 marks 20 years of continuous occupation of the International Space Station. For 2 decades now, there has never been a single moment when every human being alive has been an inhabitant of planet Earth. Since November 2000, over 240 individuals from 19 countries have lived, worked, slept and eaten on a scientific laboratory orbiting our planet at 5 miles per second. The ISS is a truly international endeavour. This episode, Nisha Birgeraz-Hoyle speaks to former NASA astronaut and space station veteran Jeff Williams to find out more about how the station was constructed and what it's like travelling 400 kilometres above the ground.
I'll start out by saying that I really appreciate your interest in telling the story about the International Space Station. The ISS, I say, often is a story largely unknown and too little told. So to tell the story, I think, is very important. One of the reasons that it's largely or not well known to the general public, I think, is because it occurred over a very long period of time. As you alluded to, I started in the mid-'90s working on it. Of course, the beginnings of it were even before that. It goes all the way back to the 80s, Space Station Freedom, and in parallel on the Russian side, they were working on their Mir space station and then planning a Mir 2. When the Soviet Union fell, of course, some smart folks got together, both on our side and the Russian side, in 1992-93, formulated this proposal to put Mir 2 and Freedom together. Both were in jeopardy to ever fly because they didn't have the support that they needed to get it off the ground. But combining it together at the fall of the Soviet Union, it provided the circumstances for the political support to come together and be sustained to actually build it. I joined the program here in terms of the space station as an astronaut in 1996, and we were heavily involved with beginning our involvement with Russia in those years by flying Americans on the Mir space station. Of course, then that set the groundwork for the ability to operate together. Our system and their system, of course, are very different, and it took a while to integrate the operations. And that was foundational to be able to then later begin building the ISS. First element launched, as you know, in 1998. It was not an easy road to even get to there, not only the political support, but the technical integration of all of these components that needed to go together. And every part of the space station was dependent upon the success of the steps that were going to go before each of those parts. When you step back and look at the whole assembly, there was I think 37 space shuttle flights dedicated to the space station. Most of those flights took up a major component of the space station. Some of them were logistics missions that supplied the station. There were also about roughly 40 Russian rocket launches that supported the assembly of the space station as well. As I said, first element launched in 1998. My first visit there was in the spring of 2000. It was the third space shuttle flight to visit the space station, which at that time was only made up of 2 modules, one Russian-built module and an American-built module. It was before Expedition 1 got there, so it was still in the very early phases before its permanent occupancy. And things were already presenting significant challenges to us. There were subsequent modules that were being delayed in their development. There were some technical issues that were slowing things down. There was financial issues on both sides, budget issues. So we launched in May of 2000 actually to fix some things that were failing on station to keep it alive. Thankfully, after our mission, there was a critical launch of a Russian component, the service module, that enabled the pathway to launch Expedition 1 in the fall of 2000. So as you're working on your piece here, of course, we're approaching the 20 years of continuous human exploration in space, which is a significant milestone, largely unknown to the general public, as I mentioned earlier. Of course, I could go into lots of details. There were many challenges along the way. There were technical issues that we had to work through. There were political issues that we had to work through. There were budgetary issues that we had to work through. There was, of course, the very significant problem and tragedy with the loss of the Columbia crew. 3 of those crew members were my classmates, so all of them were my friends. And it's not just me; they were friends and co-workers of many people here, specifically at Johnson Space Center, but they were well known in the wider community as well. So that was a very personal loss and tragedy that we had to work through. And it also, when looking back at it, it's a great testimony to the strength of the partnership, particularly between the U.S. and Russia, as we responded to that just to keep the space station going and keep it alive while we address the issues that caused the Columbia tragedy, of course, which grounded the space shuttle for over between 2 and 3 years in terms of its effectiveness to continue the assembly of the space station. At that time, we started rotating all of the crews to and from the space station on a Russian Soyuz, and it's been that way predominantly ever since. And the space shuttle, when it started flying again, was used to continue the assembly, not to rotate the expeditionary crews. My second visit to the space station was during the time the shuttle was grounded in 2006. So that became the first of 3 times that I personally rode on the Soyuz. That mission, Pavel Vinogradov and I, we were the last 2-person crew during that period of time while we recovered from the Columbia accident and returned the space shuttle to flight status. In fact, halfway during our 6-month stay, we successfully returned to flight the space shuttle with the launch of Discovery and STS-121, and they brought supplies and equipment that we needed, but they also brought Thomas Reiter from Germany, and he joined our Expedition 13 to round out the crew of 3 at the time. And that was a significant milestone because that was the first time that we had a expeditionary crew member not from only Russia and the U.S. As you know, we've got the European Space Agency. Your own Tim Peake from the UK actually flew with me. I overlapped him on my last visit up there in 2016. But that Thomas Reiter was the first partner astronaut from the balance of the partnership made up of the European Space Agency, Japan, and Canada.
One of the things I think about when I think about the International Space Station, what always comes to mind is that it's a symbol. It represents a cornerstone of the harmonizing effect space can have on nations, and how it fosters like a collaborative culture. How do you think that this collaborative culture can continue without the ISS? What has to happen from all your time you spent with everyone you've met on board the ISS from different nations? What has to happen for that collaborative culture to continue, in your opinion?
Well, I've been on orbit. I recently counted it up with 57 different individuals. And as you alluded to, many of those, that's a significant number. I was surprised when I added it all up. Many of those were from our partner agencies, Russia, Europe, Japan, and Canada. And we all collectively within the astronaut and cosmonaut corps consider this program to be very significant in that we are working as an international cooperative effort. We work very well together. The partnership is stronger now than it's ever been, and that includes our Russian partners, and that in spite of the political and diplomatic issues that have been going on for now quite a few years. We largely operate not under the radar, but under the the political and diplomatic issues that go on that are in the media and the daily news cycles. And for the most part, the different countries involved leave us alone and allow us to do our work. I think history shows that whenever you have issues between countries, if there's an engagement, largely, as I say, below the radar, below the daily public visibility, that engagement has a very positive impact in the long term to allow countries and nations to reconcile or to avoid escalation in the issues. And I trust that the ISS has been doing that, particularly between the U.S. and Russia. So I consider it a huge component of the contributions that ISS will make and will be seen in history.
And thinking about how we move on from sort of the model that we currently have on the ISS, and thinking about some of the sort of future economies that we're talking about now with the International Space Station. Naturally, so when you think about an economy, especially when it involves private companies or industries, there is always an element of competition between these companies to drive down costs, to gain contracts, for example. How do you think we can balance enabling an economy with the International Space Station while still making sure that we remember this collaborative culture that has sort of been enshrined over the last 20 years?
Yeah, that's a great point, because especially in recent years with the advance of technologies and the potential for sinister use of those technologies by stealing technology and that kind of thing, that has become it has come more and more on the forefront of how we do business. We protect data, and all the partners are this way. We protect data more than we did, say, 15, 20 years ago because of the threats out there. So that's, and then we have commercial entities that have entered onto the stage, and they, of course, they have proprietary interests that they want to protect, rightfully so. So we're growing and we're learning how to do that, how to be collaborative, how to join in partnership and combine capabilities, but at the same time honor the necessity to protect proprietary data and national security interests as well. So I think the ISS is maybe not a test bed for that, but a real world operational environment that is kind of forcing the development of that. And of course, that'll be applied to many other things in future collaborations.
I wanted to go back to something you mentioned. Obviously, you flew space flights on the space shuttle and then subsequently on the Soyuz. And obviously now recently, we've just seen the successful use of the Dragon, SpaceX's Dragon. What do you think about this new spacecraft coming out? It's quite modern. It's got modernized technology. Some of the touch screens, which we were all really worried about when we saw the touch screens, to be honest. And obviously, we've seen the SpaceX re-land their Falcon rockets, which may have taken you back to your shuttle days. What do you make of this new emerging spacecraft and space technology?
Well, it's obviously a big new development in recent years that not only SpaceX but other companies have entered the stage, if you will, of human space exploration, trying to develop technologies. Of course, a lot of it is supported by government funding, and that's necessary because until you develop the capability, it's hard to justify the development, anticipating a business model where it becomes economical. And that's the business of government. So I think all of this is appropriate. Specifically with the recent flight of the SpaceX test flight, we were very pleased with the success that we enjoyed. Obviously, it's still very early in its development, so the development is not over. We're looking at the data and working with SpaceX to continue that. There will be plenty of work to go, not only on that vehicle, but other new vehicles as well that are also in the pipeline. But it's all good. It builds redundancy. It broadens the spectrum of participants. It broadens the potential for its use in the future. It develops tools and resources that can be applied in different ways that will go beyond the space station. You mentioned the landing of the boosters. Of course, that's a new development that has lots of potential to build on the economics and the business model of being able to support launch services in this case, where you don't have to rebuild a rocket for every launch. So all of this is very good. It reminds me of the early days of aviation, when history shows about the development of the early commercial airlines, if you will. A lot of short hauls, not well integrated, not that many flights, not that many customers, relatively expensive at the time. But now we see where we are today, and the world is very dependent upon that in terms of just the normal economics and commerce of the world. People moving around all the time.
And thinking about sort of turning to the future for the International Space Station, there is a lot of debate and discussion happening right now about its fate. So, for example, obviously, I've seen a lot of NASA's communications about enabling a low Earth orbit economy, privatizing the operations of the space station. There's also been debates around reusing its components for other future space stations. Do you have any thoughts on what you think should happen to the International Space Station next?
Well, I think all of those things that you mentioned are important to look at and to try to develop, and some aspects of that will probably come to fruition because it as it unrolls, it makes sense and things fit. You know, the different interests fit, and you have the right parties interested in coming on the stage. Other things may not work, but a lot of this is sort of trial and error, and also it's dependent, of course, upon the continued success of the operation. You have to keep it flying. But no, I think it's all good. It's really, you know, we have a hard time, and the debates occur. We have a hard time seeing what the future holds because we're largely lost in the trees, and we will only see the forest in hindsight, and that's just the way it is. I think that's always been the way it has been in history. We're living in the trees, and it's very difficult to see the forest in terms of predicting where it's going to go. But it is important, I think, to maintain a low Earth orbit presence. I think that presence, and it'll be a combination of both government work as well as commercial work. That presence will be necessary, I think, to successfully develop an infrastructure at the moon and around the moon, and to conduct operations around the moon, which I think obviously the current policy is also to make that as much as practical a combination of government and private enterprise as well. And that just broadens the political support. It broadens the support in general to accomplish those things. It broadens the array of stakeholders that are interested in completing it and making it successful. So it's all good at this point.
Wonderful. I guess one thing, obviously one of the key benefits of the International Space Station, and you will have had a lot of experience of this, is it's the benefits it confers in terms of the experiments, the science it can do, the discoveries it can help towards making, not just for space flight and long duration stays in space, but also for Earth, people back here on Earth. Is there one notable science experiment that you did while you were up on the ISS that you thought when you were doing it that this could potentially be a huge game changer for people on Earth?
it's hard to pick out one. I've been involved in hundreds of them, and some of them I can't even remember or call to mind, without looking them up. But others, of course, stick in my memory.
Which one was your favorite?
Well, there's lots of favorites. There was one that was just kind of fun because we were flying, you could say, almost like robots, where we programmed them to maneuver around inside the space station. And they talked to each other. There were two of them, and sometimes we had three of them. It was called the Spheres, and it was an experiment that was developing satellite control systems. So that was a lot of fun. There was another one that just looked at fluid dynamics and the science of capillary flow. That was a lot of fun because it was visually interesting, and it's just very interesting in a weightless environment to work with fluids in different shapes. And that one turned out to be more of a breakthrough than I had known, and I didn't know that until I got back on the ground. The scientists told me what we had together discovered, and that has gone a long ways. It was one that I did actually over two flights, I think 2006 and then again in 2009 or 10. A lot of the most significant experiments for me personally, I think, though, were those that studied the human body. We do a lot of ultrasounds of the heart and other body organs that's just very interesting, and we're learning things about that. Where we breathe a little bit higher level of CO2 concentrations up there just because the equipment doesn't get it down to what we're used to here on the ground. And that has more of an impact than we originally or previously assumed. So that's been a great area of interest. And in fact, studying the human body, I think, is going to end up being one of the more significant benefits that come from the ISS, because we need to develop those countermeasures and have that understanding before we send not only back to the moon crews, but we send our first crew to Mars.
I have one more question for you. I obviously have seen your photography and some of the photos you posted on your social media, and also obviously you published a book of your photos as well. And I also know that you were part of the expedition that integrated Tranquility and the cupola in 2009? That expedition.
2010.
2010. Yeah. Sorry, yeah, it was in February, wasn't it? How excited were you? Obviously, being quite an avid photographer and very good at it. When that cupola was installed, and did you get to shoot some photography once it had been installed before you returned to Earth?
Oh, yeah, absolutely. I still had about a month and a half, as I recall, maybe a month or so on board, so I used it quite a bit to shoot photography. No, that was a big milestone. It's what I call the window on the world, because it's the only place on the space station that you can see the entire globe from a single vantage point. And you're right. I grew to appreciate very early on, even back in the 90s before I launched on my first flight, that really had to capture the experience. And the best way to do that was through photography. And I had two motivations for that. One was so that I could remember and recall the experience and tell about it. But also, probably the bigger motivation was to be able to vicariously bring the experience to people on Earth. And I prefer, personally, still photography over video, for example, because you can study and look at a photograph forever. Video goes by and the scene is gone, forever, unless you replay it, of course. So that was my motivation. And of course, the variety of what you can see from that vantage point is endless in terms of studying the Earth in the different places on the Earth and the different lighting conditions and watching seasons go by. So that was my motivation to do that. But no, the cupola is the window on the world is a fascinating place. It quickly became everybody's favorite place to hang out during their free time.
Wonderful. It sounds incredible. I would love to be able to look out at the world from that viewpoint. It must be incredible, and also perspective changing. Yes. Jeff, we are sadly out of time. I would love to sit and talk to you about the space station for hours, but unfortunately we are out of time. So I think all I have to say is, well, thank you very much.
You're very welcome.